let's talk about gravity. Gravity is the force of attraction that exists between objects whenever you have mass. And we measure that force with a simple equation of the gravitational constant times the mass of the big object times the mass of the little object divided by their distance apart squared. And that'll give you the force of gravity between any two objects. And that force will cause those objects to accelerate towards each other. On Earth, all objects accelerate towards Earth at a rate of 10 meters per second each second. So if you drop something, initially it has a velocity of 0. 1 second later, it will be falling at 10 meters per second. 2 seconds later, it will be falling at 20 meters per second, and then 30 meters per second, and so on and so forth. And that will hold true for objects both very, very heavy and objects very, very light. Sometimes, however, we observe things falling a lot slower than 10 meters per second. But that's not because of gravity. That has more to do with wind resistance. There was a famous experiment done on the surface of the moon where the surface of the moon has no atmosphere and therefore no wind resistance. Astronauts took a feather and a hammer and dropped them, and what do you know? They hit the ground at exactly the same rate. So on the MCAT, whenever it talks about gravity, you can assume that something is falling at 10 meters per second. There is one more equation you should know, and that is what we call the free fall equation. And that is simply that the distance something falls is equal to 1/2 times the acceleration from gravity times time squared. And again, that acceleration from gravity will always be 10. Here's a simple free fall problem. Again, our standard equation for dropping an object from rest is the distance the object falls is equal to 1/2 times the acceleration from gravity times time squared. In this case, we're trying to figure out how far it falls, so we don't know x. But we do know acceleration and we do know time. So we could write the equation that x is equal to 1/2 times the acceleration from gravity times our time squared, which in this case is 4. Or x is equal to 5 times 16, or 80. Now, the only thing to be careful of is they're not asking for how far it fell, they're asking for how far it has left before it hits the ground. So the real answer would be its initial altitude minus the 80 it fell, giving us a height of 20. Here's another free fall equation that on the surface may look more complex. Last time, we took an object and we dropped it straight down. This time, we're starting off our problem by throwing our object to the right. So it begins its fall with a horizontal velocity, so when it falls, it has this nice curved path down to Earth. So the question is, how will the horizontal velocity affect its acceleration towards Earth? The answer is, it won't. In fact, there's a famous physics experiment that if you took a bullet and shot it out of a gun, and at the same time dropped a second bullet straight down, the two bullets would hit the ground at the exact same time. So horizontal velocity does not affect vertical acceleration. So we can actually ignore the 30 meters per second. So our equation is real simple, just like last time. The distance the object falls is equal to 1/2 times the acceleration of gravity times time squared. This time we know we're falling 40 meters, so 40 is equal to 1/2 times 10 for acceleration times time squared. And that's your equation. So 8 is equal to t squared, and you could approximate that to be roughly 3.